So I want to start at the beginning of this problem using Cramer's rule because we had to rush through it. So I'm going to just solve for x. Solving for y and z is exactly the same procedure. So first we're going to write our matrix that goes with this system of equations. We've got our coefficients on the left, 2, 1, and 2 from the first equation, 1, 1, and -1 from the second equation, 3, -1, and 2 from the third equation, and then we have our constants on the right side of the line, 7, -2, and 16. So to solve for x, this is what we would do. We would have the coefficient matrix in the numerator, the determinant of the coefficient matrix, with the x column replaced by the constants 7, -2, and 16. The other two columns are the same as they were, the y column, the z column. And then in the denominator, we have the determinant of the coefficient matrix, just the way it is. That's how we would solve for x. To solve for y, we would do the same thing. The denominator is still the determinant of the coefficient matrix, but now the numerator has the y column replaced with the constants, 7, -2, and 16. To solve for z, we would have the same exact thing, but the denominator is still the coefficient matrix, but the numerator now has the z column, the third column, replaced with the constants. So this is how you set up Cramer's rule. We're just going to compute x. So the first thing you're going to do is choose which row you're going to work with this determinant in the numerator for x. So I'm going to work with the first column just because it leaves me with all the really simple numbers for the determinants that I'm going to have to do, the 2 by 2 determinants. So I'm going to use the first column. So the first thing I'm going to do is find the minor of 7. So I'm going to cross out the first row and first column where 7 lives, and I'm going to have 7 times what's left, the determinant of what's left, 1, -1, -1, 2. And then once I find that, I'm going to have to multiply it by -1 raised to the row plus column. So first row, first column, 1 plus 1. All right. Now I'm going to move on to the next number in that column I'm working with, -2. So I'm going to cross out the row and column that -2 is in. And then I'm going to multiply -2. I'm going to add this to what I just had, the pink thing. I'm going to add this to that, -2 times its minor, which is 1, 2, -1, 2. So it's what's left after you cross those out. And then I'm going to multiply that by -1 raised to the row plus column. So this time the row is the second row and it's still the first column. All right, next I'll move on to 16. So I'll cross out the row and column that 16 is in. And I'll add 16 times the determinant of the minor, which is now 1, 2, 1, -1, times -1 raised to the row plus column, third row, column 1. And then I'll move on to the denominator. So the denominator now, I'm going to work with the first column just because all these numbers are simple, but I'm just going to work with the first column again. So I'm going to cross out the first row, first column where 2 is, and so that will give me 2 times the minor, which is 1, -1, -1, 2, the numbers that are left, and I'm multiplying that by -1 raised to the row plus column, 1 plus 1. So now I'm going to move on to the 1, the second row, first column, and I'm going to cross that out, the row and column where the 1 is, and I'm going to add to what I already have, 1 times what's left, the minor, 1, 2, -1, 2, the determinant of that, and then -1 raised to the row plus column, second row, first column, and so that's what I have for that part of it. Then I'm going to do the cofactor of 3. So 3, cross out a row and column. What do I have left? I'm going to add this to what I already have, adding 3 times the minor, the determinant of the minor, 1, 2, 1, -1, and then multiply that by -1 raised to the row plus column, third row, first column. So I've got all this stuff, and this is going to give me the value of x. Now I just need to multiply it all out. So if we multiply out the pink thing on top, we've got 7 times 1 times 2, which is 2, minus -1 times -1, which is 1. And I'm going to multiply that by -1 squared, which is 1. Then next thing I'm doing is adding the blue thing. So -2 times 1 times 2, which is 2, minus -1 times 2, which is -2. And I'm going to multiply that by -1 cubed, which is -1. Then I'm going to add 16 times 1 times -1, which is -1, minus 1 times 2, which is 2. And I'm going to multiply all that by -1 to the 4th, which is +1. So that's my numerator. Denominator, I've got 2 times 1 times 2, which is 2, minus -1 times -1, which is 1. -1 squared, again, is 1. Now I'm going to add this. So 1 times, so I don't really need to write that. 1 times 2 is 2, minus -1 times 2 is -2. Multiplying that by -1 cubed, which is -1. Last of all, I've got 3 times 1 times -1, which is -1, minus 1 times 2, which is 2. And I'm multiplying that by -1 to the 4th, which is just 1. So on top, I've got 7 times 2 minus 1 times 1, which is just 7. Then right here, I'm going to do this one. I've got -2 times 4, which is -8. And then multiply that by -1, so it's +8. And then last of all, I've got this. So that's 16 times -3, which is -48. And then in the denominator, my first term, I've got 2 times 1, which is 2. Then I'm going to add 4 times -1, so -4. And then here I have 3 times -3, which is -9. So we've got -33 on the top. On the bottom, we have 2 minus 4 is -2, minus 9 is -11. So x is 3. So remember that this method of finding determinants is called the method of cofactors. This is the method you should be using, not the method from lesson 101. So we have some matrices here, and we're going to talk about the order of each matrix. The size of a matrix is called the order of the matrix and is defined by first indicating the number of rows and then the number of columns. So whenever you talk about the order of a matrix, it's going to be rows first by that X sign columns. So this first matrix right here has 2 rows, 1, 2, and 2 columns, 1, 2. This next matrix has 2 rows and 4 columns. So we call it a 2 by 4 matrix. This matrix right here has 3 rows and 1 column. So we call it a 3 by 1 matrix. This matrix has, again, 3 rows, 1 column, 3 by 1. This matrix has 1 row and 4 columns. So it's a 1 by 4 matrix. So remember, rows have to come first. All right, you can only add, we're adding matrices now. This is pretty simple. We can only add two matrices if they have the same order. So in this problem right here, you've got a 2 by 3 matrix, and you want to add it to another 2 by 3 matrix. That's how it has to be. You can't add two matrices that don't have the same order. And all you have to do to add two matrices is add the elements that are in the same position. So the first row, first column is a 4, first row, first column is a 6. So you add those. First row, second column, 2, -3, you add those, and that goes in that position. 3, add it to 4, and that goes in that position. So you just add the elements that are in the exact same position in each matrix and put them in that position. So your solution, your sum of those two matrices is 10, -1, 7, 7, 2, 5. So adding matrices is not so bad. And matrix addition is commutative, just like regular addition is. Or addition of real numbers. 2 plus 3 equals 3 plus 2, which is 5. That's called the commutative property of addition. That same property works with matrices, matrix addition. So it doesn't matter if you put this matrix first or this matrix first, you're going to get the same thing. So if I put this second one first, in this case, I've still got 6 plus 4, which is 10, -3 plus 2, which is -1, 4 plus 3 is 7, 6 plus 1 is 7, 2 plus 0 is 2, and 0 plus 5 is 5. You get the same thing. The additive identity for matrix addition is what is called a zero matrix. So remember, when you're adding real numbers, the identity is 0, because if you add a number to 0, the number doesn't change. It keeps its identity. So 0 is called the additive identity. Well, in matrix addition, you also have an additive identity, and that is a 0 matrix of the same order as the matrix you're adding to it. So if you add this matrix to a 0 matrix, you get the same thing you had before, because you're just adding 0 to each element. A matrix can also be multiplied by a number or by another matrix. And there are actually two kinds of matrix multiplication. One is called finding the scalar product, or scalar multiplication. When we're working with things like matrices and vectors, things that have more than one number encased in them, when we're working with those kinds of things, we call a regular whole number, a single number, we call it a scalar. It's just so that we don't get confused with what kind of numbers we're talking about. So a scalar just means a real number. So in this first product here, we've got -2 times this matrix. The -2, we would call it a scalar, because it's not a matrix. It's just a real number. To multiply a scalar by a matrix is also pretty simple. You just multiply that number by every element in the matrix. So -2 times 4 gives us -8. -2 times 1 gives us -2. -2 times 6, -12. -2 times -5 is 10. -2 times 2 is -4. And -2 times -2 is 4. So again, this is not so bad. It's pretty simple. To multiply 3 times this row matrix, we call this a row matrix because it just has one row. Again, you're multiplying 3, which is a scalar, by a matrix. You just multiply it by each element. So 3 times 1 is 3, 3 times 3 is 9, 3 times 6 is 18, 3 times 2 is 6. And that's your new matrix, the product. Now, when we multiply two matrices, it's a little different. It's a little trickier. First of all, you can only multiply two matrices if the first matrix has the same number of columns as the second matrix has rows. So you can multiply a 3 by 2 matrix by a 2 by 2 matrix, that's fine. But you can't multiply a 2 by 4 matrix by a 2 by 4 matrix because these two numbers have to be the same. The columns of the first matrix have to be the same number as the rows of the second matrix. And your solution, your product, will end up being this by this. So if you multiply a 3 by 2 matrix by a 2 by 2 matrix, you're going to end up with a 3 by 2 matrix. So the answer, the product, will have the same number of rows as the first matrix and the same number of columns as the second matrix. So it's a little trickier, but once you go through it a few times, it will make sense. Trying to talk about it in this form right here is confusing because it's just, it's just a bunch of, all these subscripts just don't make it clear what exactly is happening. So we're going to look at it with pictures to kind of get a better idea of what matrix multiplication looks like. So let's say that we wanted to multiply these two matrices, 1, 2, 3, 4, 5, 6 for the first one, which is a 2 by 3 matrix, and then 7, 8, 9, 10, 11, 12, which is a 3 by 2 matrix. So this works because the middle numbers, the columns in the first one and the rows in the second one, match up. They have the same number, so we know we can do this. And we also know that our product is going to have 2 rows and 2 columns, the outside numbers. So it will look like this. All right, so we're going to just do this step by step so you can see what happens. So we start by going across the first row and down the first column. So across the first row of the first matrix, down the first column of the second matrix, we're going to multiply the 1 times the 7, and then we're going to add the 2 times the 9, and then we're going to add the 3 times the 11. And we add that up, and we get 7 plus 18 plus 33, and that's going to be 58. And that is what will go in our first row, first column. So I'll just go ahead and put it up here. All right, now we move on to the first row, second column. So first row again, second column of the second matrix. And we would do this, we'd stick with the first row until we went through all the columns of the second matrix. So we're going through across and down, across and down. So we'll do 1 times 8 plus 2 times 10 plus 3 times 12. And that's going to give us this position right here. So 8 plus 20 is 28 plus 36, which is 64. So that's 64 right there in the second column of our product, because we went across the first row, second column. So that's first row, second column. There are no more columns in the second matrix, so we'll move on to the next row of the first matrix. So we've got the second row, and we're going to go down the first column of the second matrix. So 4 times 7, we got the 5 times the 9, we're adding 5 times 9, plus the 6 times the 11. And if we add all that up, we get 139, and that will go in the first column, second row of our product. So 139. Now we're going to stick with the second row of our first matrix, multiply that by the second column of the second matrix. So we're going to do 4 times 8 plus 5 times 10 plus 6 times 12. So that's 32 plus 50 plus 72. And if you add that up, you get 154, and that goes right there. So 154. So that is how you multiply two matrices. You go across and down, matching each row in the first matrix with each column in the second matrix. All right, so we're going to do a few more examples. This is subtraction. So when you subtract a matrix, it just means that instead of adding the elements, you're going to subtract them. So this is not multiplication, this is subtraction. We're just doing another example. So these two matrices are the same order, which means we can add them. So we just add each element that is in the same position. Well, we're subtracting. So 4 minus 3, and then 2 minus 5, and then negative 2 minus negative 4, and then 6 minus 4, and 3 minus negative 2, and 5 minus 6. So 4 minus 3 is 1, 2 minus 5 is negative 3, negative 2 plus 4 is 2, 6 minus 4 is 2, 3 minus negative 2 is 5, and 5 minus 6 is negative 1. So that is how you would do that subtraction problem. All right, now we're going to multiply. We've got a 3 by 2 matrix here and a 2 by 2 here. And so we know we can do this because these two numbers are the same and our product will have these dimensions. So it's going to be 3 rows and 2 columns. All right, so we're going to start with the first row, first column. So first row, first column, 2 times 1. We're going across and down. So 2 times 1 plus negative 3 times 4. That is 2 minus 12, which is negative 10. So that goes right here. Now we're going to go down. We're going to go to the second column. So 2, negative 3 times 2, negative 5. So 2 times 2 plus negative 3 times negative 5. We're going across the first matrix and down the second matrix. 4 plus 15 is 19. So that goes here. Now we're going to move on to the second row of the first matrix and go through the columns of the matrix on the right. So 3 and 1 is going to go with the 1 and the 4. So 3 times 1 plus 1 times 4 is 7. That goes here. Now we're going to move to the second column of the second matrix. 3, 1, and 2, negative 5. So 3 times 2 plus 1 times negative 5 is 6 minus 5, which is 1. So that goes here. Now we're going to move on to the third row of the first matrix. So 4 times first column of the second matrix, 1, and 5 times 4. That is going to be 24. So 4 times 2 plus 5 times negative 5, and that is 8 minus 25, which is negative 17. Okay, now we're going to multiply these two. This is a 3 by 3, 3 by 3, and so your answer is also going to be a 3 by 3. You can see that this one has lots of zeros in it, which is nice. So we're going to go across the first row, down the first column. So first row, first, well, I'm not going to write that out. You just have to follow me. So going across the first row, down the first column. So 0 times 1 plus 1 times negative 1 plus 2 times 0. So you got negative 1. That goes here. Now we're going to go across the first row, down the second column. That is, I'm not even going to write it out. It's just so many zeros. So 0 times 0 is 0. 1 times 0 is 0. 2 times 1 is 2. So that goes here. Again, we're going to go across the first row down the third column. So 0 times 1 is 0. 1 times -2 is -2. 2 times 3 is 6. 6 and -2 is 4. You probably don't really even need me to go through this, but I'm going to do it. All right, we've done all the columns in the second matrix, so now we're going to go ahead and move on to the second row of the first matrix. Across the rows, down the columns. So second row, down the first column, -1 times 1 is -1, and then you've got 0 and 0, so -1. Across the second row, down the second column, you've got 0 plus 0 plus -2. Across the second row, down the third column, you've got -1 plus 0 plus -6, so that's -7. Now we have done all the columns for the second row. We'll go ahead and do the third row. So third row, 3 times 1 is 3, 4 times -1 is -4, 0 times 0 is 0, so you've just got 3 minus 4 is -1. Move on to the second column, 3, 4, 0 times 0, 0, 1. You've got 0 plus 0 plus 0 is 0. Now we'll go to the last column, last row, last column. 3 times 1 is 3. 4 times -2 is -8. 0 times 3 is 0. So you've got 3 minus 8 is -5.